Okay, good afternoon. I hope you enjoyed the break. Okay, my name is Pietro Evangelista. I'm a research director in logistics and supply chain management at the Institute on Research and Innovation for Development of the Italian National Research Council. I was awarded a PhD in logistics by Heriot-Watt University, and I was also awarded Jim Cooper Memorial Cup from CIOT UK in 2010 for prizing my dissertation as the best dissertation in logistics in UK and the Republic of Ireland. I carried out extensive research in economics and management issues associated with the port and maritime logistics. I also carried out research in the field of ICT dissemination in logistics and logistics service provider. And my current research interest is in decarbonization strategy for freight transport and logistics. I sit in the editorial board of several high-ranked journals in the field of logistics and supply chain. I also member of the research committee of the European Logistics Association, and I teach green logistics at the Lappeenranta Institute of Technology in Finland. I would like to say thank you to the previous speakers for their very interesting speech. And I also would like to thank Danuta for moderating and organizing this first part of our event today. So let me introduce Professor René De Koster, that I am very happy and honored to introduce you. So let me say some few words about him. He is Professor of Logistics and Operation Management at the Department of Technology Operation Management, Rotterdam School of Management, Erasmus University. He is also the chair of this department. René research interests are in warehousing, material handling, container terminal operations, behavioral operations, and sustainable logistics. He is author and editor of 8 books and over 230 papers published in books and very high-ranked journals. He is also in the editorial board of a large number of very high-ranked journals. He is also member of the Research and Development Committee of the European Logistics Association. He is also a member of the BWL Scientific Advisory Board, that is the German Logistics Association, and also chairman of 2 Dutch Logistics Awards in the field of academy, I think, and chairman of Stichting Logistica and founder of Material Handling Forum. So, Professor De Koster will presenting this afternoon a very interesting presentation on, the title is Logistics and Supply Chain 2030. And the content of the presentation is focused on analyzing a number of emerging digital technology and related application in the field of logistics, transport, and supply chain. He also discuss positive and negative, pros and cons of each of these technology. And so he will give a very comprehensive overview of the application of this technology in our field. So please, René, can you start? Hello, René. René,
Can everyone see my screen?
Yes.
Okay, great. Thank you very much, Pietro. So I'm happy to be here today and to present some of the developments in logistics and supply chain.
Questa è la sua email.
René, sorry.
René, you have your inbox.
The view is different.
Okay.
We see your mail.
Okay, I share again.
Ha sbagliato, capito? Ha messo la sua posta elettronica.
Can you now see my screen?
Yes.
Yes,
Okay.
perfect.
I'm very sorry that it's okay. Anyway, you can see it now, so let's just continue where we were. So I'm going to talk about a couple of developments in logistics and supply chain. Of course, this is just my perspective, and you don't have to share my views on these technologies that I'm going to shed some light on. So what I want to do is just give some positive and some negative aspects of some of the developments that we have seen lately. And I use the Gartner's technology hype cycle, you might say, as a sort of a lead. So here you can see a lot of technologies. You're all familiar with that, I guess. And Gartner typically divides all these developments and technologies in 4 stages, or 5 stages, sorry, starting by innovation and the peak of inflated expectations, as they call it, because typically we see huge expectations of certain technologies, and then necessarily we see also the trough of disillusionment. So we are disappointed in what these technologies really bring. And then after some time, we see that some of the technologies indeed might still bring something. And that's what Gartner calls the slope of enlightenment. And then we see the plateau in which the technologies are really used. So I just picked a couple of these technologies, and I have 40 minutes, so I cannot treat everything. I just took my pick. It shouldn't be your pick. It's just my personal view on some of these things. And many of them are a bit closer to my own research subjects, and that's why I chose these developments. I could have talked about other things as well, obviously, but in 40 minutes, I think this is what I can cover. So I want to start with container terminals. We already heard something about container terminals, or at least in the Chinese Belt and Road Initiative from our first speaker, Professor Sijic. So I'm going to address briefly what container terminals are bringing for new technologies. Then automated warehouses, collaborative robots, drones, autonomous vehicles, well, and a couple of other things. Let me just start. So this is a picture of a container terminal. This is in Belgium. It's in Antwerp, the MSC home terminal. And this is a completely conventional terminal. It's operated with straddle carriers. Now, what is a straddle carrier? It's a thing that looks like this. To be honest, it's slightly different than this because these are unmanned straddle carriers, while most straddle carriers are just manned. So there's a driver in this truck, and the truck can drive through the stack of containers, pick up a container and bring it to a sea-going vessel, or bring it to a truck that is waiting in order to bring the container inland. However, what we see now is that gradually we are seeing more and more automation. So this is a picture, an aerial view of one of the recent automated terminals. This is CTA, Container Terminal Altenwerda in Hamburg. And this terminal is rather unique in some aspects. So the aspects that are not unique are the automated guided vehicles. They drive between the seaside of the terminal. Can you see my mouse, by the way? Can you see that?
Yes.
Yes.
Okay, great. So this is called the seaside. These are the K cranes. This is the stack. This is the land side with a train terminal. Now at the seaside, there are automated guided vehicles which transport the containers between the C cranes, the K cranes, and the stack cranes. So these are automated. Then the stack itself is operated by automated stacking cranes. They look like this, and this is pretty special because these stacking cranes are not really twin cranes. They are cranes of which one is bigger and the other one is smaller. They can drive over each other. So the big crane can drive over the lower crane. And that helps to bring containers from the land site immediately to the sea site without handover. So both the big cranes and the small cranes can bring trucks from the land site to the sea site or vice versa. And you might see even more advanced types of container terminals, at least on the drawing table, like this one, which is operated using a sort of mesh wire grid with cranes on top, gantry cranes on top, which can immediately move containers from the land side to the sea side via this overhead crane system. However, this is only a drawing board. This is not real. So one of the most advanced automated terminals, I think, is in Rotterdam now. So we have two of those, the one operated by Rotterdam World Gateway, and the other one is operated by APM. That's a daughter company of Maersk. So what do these highly advanced automated sea terminals look like? Well, first they have not single hoist gantry cranes. So these are the gantry cranes, but they have double hoist gantry cranes. Because one of the problems that they are facing is the ships are getting bigger and bigger, meaning they get higher and they get wider. So current container vessels are already 25 boxes wide. And that means it takes a lot of time to move a box from a vessel to, let's say, a vehicle. And well, we can have more, since the vessels are big, we can have up to 6 container K cranes working on a vessel, but still the productivity is not big enough to offload a big vessel of, let's say, 22,000 TEU or 22,000 small container equivalents. That's the capacity of a big vessel nowadays. So what we see now is that these big automated container terminals have K cranes with double hoists. So they can work on 2 containers at the same time with 2 different hoists. And some of these hoists can even lift up multiple containers at one hoist. So we have 2 hoists potentially capable of lifting more than 1 container each. This is helping to increase the throughput capacity enormously. But this is also needed because the cycle time is longer, right? Because of the big vessels. Second, these K cranes are no longer operated by a human in the K crane. They are remotely controlled. So someone in India might control the cranes, and this person does not control 1 crane. Person can control up to 8 different cranes simultaneously. So in the past, we lost a lot of time for operators climbing in the crane, shift brakes, for example, or other brakes. Now we don't lose time for shift changes because it's just office time. The third development is all these vehicles are now electric. In the past, they were powered with diesel engines, but now the AGVs, automated guided vehicles, are now electrically powered. So these are just electric trucks. And the newest one are not AGVs, but they are ALVs. And ALV stands for an automated lifting vehicle. And the lifting vehicle has a huge benefit over an AGV. And the benefit is that an AGV requires a hard handshake between the stack cranes and the vehicle. So the vehicle has to be present for the stack crane to offload its container. However, this is not needed for ALVs. The stack cranes can just drop off a container on a frame, and the ALV can come later and lift it from the frame and then bring it away. So we can reduce the number of vehicles needed on the terminal because they're just decoupled. What is also a development? Well, another development is automated stack cranes. So this is the stack. We see 2 cranes in every stack lane. These can be elevated like this, or they can be ordinary twin cranes, so identical cranes, but these require a handover if a container moves from the land side to the sea side. So these cranes are not very popular. So the other ones are in fact better in view of space consumption and throughput capacity. So we see more twin cranes now in most terminals. And the thing is, we see these terminals everywhere. So not just in Europe, where it started in Rotterdam more than 20 years ago, but we see it also now in Asia, And for example, even in China, where you might say, hey, it's needed there because the wages are a bit lower. Even in China, we see now automated terminals. So the main motivation is not only driven by lowering labor cost, it also has to do with bigger vessels, more accurate performance, more predictable performance, and to be honest, in many cases also lack of available labor, because this is really a 24/7 operation. And in regions like Rotterdam, it's very hard to find people who are willing to operate in such type of shifts in remote places like container terminals, because these big container terminals are far away from the city. In Shanghai, the Yangshan terminal is about 50 kilometers away from the city. It might even be more. And in Rotterdam, it's about the same. So it takes some time to get there. So automated container terminals everywhere in the world gradually, particularly the big ones. So all major container terminal operators in big deep sea ports are considering to automate. If they are not doing it now, they will do it in the near future. Unfortunately, they are extremely expensive, so they require huge investments. So you have to think of starting as of 500 million. And I'm not talking here about the quay itself, I'm only talking about the equipment. And still, although they have a very high throughput capacity, they are completely inflexible. So the example was already given of the Ever Given, a vessel that was stuck in the Suez Canal for 6 days. And according to BBC, this led to delay cost of $400 million per hour. So one of these vessels carries for many, many billions of euros in cargo. So the value is incredible. And there were so many vessels stuck. So the damage was 400 million per hour. And this will cost months to work away in the deep sea ports. So 6 days of delay, and the delay will be months in order to work it away. So that has to do with, well, the capacity is high, but completely inflexible. So there are some downsides to all these automation as well. Why is it so inflexible? Well, you have to think also, it's not only the handling capacity of the terminal, but also the stacking capacity. You also have to get away all these containers to the hinterland. And that takes an enormous amount of time to organize all these flows. So the next development, fully robotic warehouses. And these do exist. So it's not something that you might think is infeasible. No, they really exist. Let me give you some examples of warehouses without people. Well, with very few people, I should say, because without people, that doesn't exist, but with very few people. This is an example of a warehouse in Germany, Etna, a wholesaler, and all the flows from unloading a truck to loading a truck, everything in between is automated. Another one, this is Coop in Norway, close to Oslo. So this is a grocery retail warehouse. And you see different compartments here. All these compartments are the different temperature zones. So they have a deep freeze, ambient, but also different refrigerated zones. And all these zones have their own automated technology. So trucks are offloaded automatically. Things are stored and then retrieved, picked, sorted, and put in a roll container for the stores automatically. This is a warehouse of Albert Heijn, the largest retailer in the Netherlands. So this became operational last year. Also a grocery retailer. And this is JD.com in Shanghai. And let me show you the video of JD.com. You can find it on YouTube. part measurement gain is based on the size of the order. This kind of trying to hold it in cuts on the spot. Are the robots, tiny floors. We are sorting the parts in the right code. Two levels. We have the robot, in the right hole. The clear code of the part ends up in the back. And the robot the right. So even in China, we see these fully automated warehouses. JD claims that there are only 4 people working in his warehouse. To be honest, this is not really true, because this is just one part of the warehouse. The major part of this warehouse is still manual. But still, you see all the technologies appear to work. So what is the typical flow diagram of such an automated warehouse? So it looks like this. We see that inbound trucks arrive. Then typically goods are palletized. They're stored automatically via a conveyor system in an automated storage and retrieval system. This is a conventional system. They are around already since the 60s, stored in pallet racks with high bay cranes. Then the units loads are retrieved and they are destacked into individual products. And these individual products go into another robotic system, which is called an AVSR system, autonomous vehicle-based storage and retrieval system, where every unit of a product can be approached individually. When an order arrives of a customer, then the products of that customer are retrieved from this system. They are sequenced. And in the case of store-based retail, you have to stack them in a roll cage or on a pallet. And robots are used to stack it in the right sequence depending on that customer, on that roll cage or on that pallet. And if the pallet is complete, it goes into a buffer and it waits there until the truck has to depart. And then all the pallets and roll cages for the truck are retrieved from the storage system and sequenced in the right sequence. So that's the reverse sequence of unloading. And they're loaded into the trucks. And for that, you can again use a sorting system also, an automated sorting system, using AGVs or small autonomous mobile robots like sketched here. So this is typically how it works. So we see a lot of different systems, robotic systems, glued together, organizing the total process. Now, the big revolution in all these systems is here. So this is the big revolution of the last, you might say, decade, 10, 15 years. That's the ability to make mixed pallets completely autonomously by these robots in the sequence that's demanded by the customer. And these pallets are built better than a human can do it. So they are more full and also better stacked. So leading to less replenishment work in the store. So they are completely store-based or customer-based. So since this has now become possible, we see all of a sudden more and more of these warehouses. However, if you look at these warehouses in a bit more detail, I have to say they are extremely expensive. So a very long payback time, and to be honest, I doubt they ever will pay back in view of the margins that these retailers have per unit picked. But still, this is a development going on, and we see that all retailers are doing it. So to be honest, I don't think the main driver for this automation is not cost saving or doing things more efficiently, or as you might call it. No, the main driver is the lack of resources. So retailers are working more and more 24/7. There are no people available willing to do the work at night. So if there's no people available, they have to choose for these types of automated technologies. But that does not mean that you should go for automated warehouses if you're not a grocery retailer, because that's where you typically find them. So they are not affordable for most operations. Okay, let's look at some other type of robots, collaborative robots. These are a very specific type of robot. It's basically a system that's not as automated as a fully automated warehouse, but it is a system where people can work together with robots. They collaborate. So here you see an example of an order picker with a headset, and this is a robot following the picker. Locus is one of the suppliers of these types of robots. So this is a video where you can see that all kinds of small robots. This robot is waiting here for a picker. This picker helps the robot, and then she's helping that robot. So robots are used to collect a complete order, and the pickers are just adding to the right robot the right quantity for that order. The question, of course, is, well, does it really help for performance? That's a question you might ask. But also, how do people engage with these robots? So what is the best way of working together with these robots? We have done some research, so I'm just going to shed 5 minutes of my time with you about what are the results of that first study. So what is the impact of people working together with such type of robots? So the research question we want to answer is, which order picker should use which pick support AGV system or robot system? So we did it with an experiment in our lab, and we have two variants. The robot is in charge and the picker listens to what the robot tells. And the second one is the picker is in charge and the robot listens to what the picker tells. Okay, so these are the two different variants of that scenario. We see a small robot. In the case human leading, the order picker has a wristwatch with a terminal telling the picker what he should pick and where. And the robot just follows the picker. He drops it off and then confirms on his wristwatch, on his wrist terminal, what he just did. This is the second setup. The picker follows a robot, and the robot has a terminal mounted on it, and the terminal tells the picker what he or she has to do at the position where the robot stops. So the robot stops at the pick position and tells then the picker what he or she should pick and to drop it off in that tote. After the order is complete, the robot leaves to a packing station and it's immediately switched by a second robot. So the picker is continuously picking. The picker does not lose time by fetching a new empty tote or bringing away a full tote. The robot takes care of that. So let's look at some results that we obtained. First, this is the setup of the experiment. So well, the whole experiment took about 1.5 hours, consisting of 3 runs of picking. So one first was a manual picking round, then first where the human was leading, and another one with the robot leading or the human supporting the robot. And this was just randomly sequenced for every participant. And they also had to fill out a couple of questionnaires related to the personality and also to subjective findings of the experiment. So let me just look at some of the results. So the first result focused on what is the effect on productivity of human leading versus robot leading. So the dependent variable here is the total productivity. And you see that when the human leads compared to the robot leads, we achieve a much higher productivity. So 5 lines compared to 60 lines in the time period, 5 lines extra. So that's a substantial productivity increase when the human is leading rather than when the robot is leading. So this suggests that in order to achieve a maximum productivity, you should not let the people follow a robot, but let the robot follow people. However, there is a downside. And the downside is when you look at quality, the reverse happens. So the dependent variable here is errors, inaccuracy, total errors in 20 minutes of picking. And what we see is that on average, there's about 4 errors, but if you have the scenario with the human leading, so the robot following, we have 0.6 errors more, which is a substantial increase in the number of errors. So yes, it's good to have the human leading for productivity, but it's not so good for errors. We should do the opposite. Let the robot lead if we want to reduce errors. However, this also depends on the personality of the picker. So we looked into a regulatory focus of the picker, and the regulatory focus of the picker tells, well, there are basically 2 types of regulatory foci. And the first one is called a prevention focus. So people can be more prevention focused, or they can be more promotion focused. Regulatory focus tells how people try to achieve goals in their work. So it's a regulatory focus at work. How do you want to achieve your goal? Prevention focused people try to achieve the goal by basically circumventing things that prevent them from achieving the goal. Whereas promotion focused people go for that goal more directly. And you see that there is an impact of prevention focus on the productivity. So what is that impact? So what you can see is on the vertical axis, you see here the pick time. So higher pick time is lower productivity. So lower is better in this case because it's time for a pick. And we have the 2 scenarios here, human leading robot and human supporting robot. What we can see is that if the human is leading robot, yes, we have a much lower pick time than when the human is supporting the robot. But there is a big difference for people with a high regulatory prevention focus and people with a low regulatory prevention focus. So people who have a high regulatory prevention focus, there's basically no difference or hardly any difference. So all the productivity gain that you see when the human is leading the robot comes from people with a promotion focus. These are the ones for which who really should lead rather than the robot leading, because people with prevention focus can completely mitigate this benefit of human leading. So what we might do is, if we want to have a scenario with robot leading, we just select people with a prevention focus to do the work, because then we can achieve the same productivity. That's sort of the message you might conclude. So we also have some results with respect to what extent do people like it to work with robots, but that's still ongoing. So this is people collaborating with robots, but of course we can also have robots do the work completely. So these are not really collaborative robots. They are robots that can do the work, but in combination with people, independently. So that's the newest development. Okay, I'll skip the video. This is an example of collaborative robots where the order picker is also a robot. So the robot collecting the order is one robot, but the order picker is another robot. They just collaborate. The robots collaborate here. This is fetch. So what can we conclude about that? Yeah, so there are some positive sides. So people really like it to work with robots. That's at least one of our conclusions we had. So they can make the work of pickers more attractive. But I have to say this is in theory, because it depends a lot on what people really are doing with these robots. If you use the robots to do the easy part of the work, and just to make people more productive, there is a risk that the work for the people becomes, you might say, more boring rather than more interesting. And another downside is they're still very expensive, these small robots. And also what we found is that from practice, not from our experiments, is that although it looks nice and it looks like, yes, the robots take care of, for example, moving picked totes to the packing station, so the picker can be more productive. The productivity increase is not such that you can basically make a business case of these robots, because you still need about 1.5 robots for extra picker for every picker that you have. So 1.5 robots, let's say these things cost about 40,000 each, is still 60,000 investment in robots to support one picker. So the question whether that's makes a business case or not. However, I expect that these prices will drop in the near future, and then the business case might really arise. So one of the next developments, that is drones. Well, drones are becoming more popular in many areas. You read a lot about it. So they can be used, for example, for stock taking, for security in warehouses, for sorting, but also for parcel delivery. So there are different applications of drones. This is an application for stock taking. So one of the companies that really went very far with this is Walmart. Walmart implemented the Bossa Nova robots in, I forgot the exact number, but it was a huge number of stores where they implemented these robots. So an order of magnitude of at least 1,000 stores where they implemented them. So this is a picture of the Bossa Nova robot. So it just scans the entire rack facing in the store and is then able to tell exactly which products are there, what the expiry dates are, which products are missing, how many units. At least that's the idea. And it can do that completely autonomously, thereby triggering replenishment, for example. So having installed all these robots in this large number of stores and all this positive press, last year, November, Walmart announced they would abandon the project. So they had invested heavily in developing these robots. It took them 10 years to develop and implemented them in 1,000 stores, it says here. So that's, but they abandoned the project all of a sudden. Well, in the spring, they still announced that they wanted to expand the project. So drones also have some limitations, to be honest. So yes, they have some advantages. For example, they can deliver to remote places. They can deliver relief aid, but organizing it on a large scale is really, really difficult. And in warehouses, the application possibilities are really very limited. So in unit load warehouses, it might work a bit, but in stores, it just did not work. Now you might imagine, why didn't it work? Maybe any one of you has an idea why it would not work to count inventory with these robots. Any one of you has an idea? I thought let's do it a bit interactively. So let me just ask a question to you.
Sorry, René, can you repeat the question?
So my question was, why don't these robots taking stock not work in stores? Why doesn't it work? Well, there are many reasons. Let me share some of them. In a store, let me go back to the picture of the store. This is the store of Walmart, right? Store facing. First, what you see is that how can you see behind the first products? It's very hard to look behind them. You cannot see whether the shelf is empty beyond the first row. Second, in many cases, it happens that customers displace products themselves. So they hide it behind other things. So for example, shelf life is very hard also to see on a shelf. So basically the items are hiding the other items. So you cannot see everything. And that's what Walmart found out after 10 years of developing these robots. So it's really much more difficult than it seems. And the same is true in warehouses. So in the first row, you can see, behind that, you cannot. And also items can be rotated or shifted. And then how can you identify the product for sure if you can't read the barcode or whatever? So in a warehouse, it's more easy to organize, but even there, it does not work beyond unit load warehouses.
René, sorry, 1 second. There are 5 minutes remaining that I would like that you conclude your presentation and postpone all the questions in the round table. Because
yes, let me see what I like.
No, please go on, because they're very, very interesting presentation.
Yeah, I just want to check what other item I would like to address.
Even if you have just 5 minutes. Sorry for that.
Let me just see what is a bit nice. Okay, maybe green logistics. That's another interesting development, right?
Yeah.
So we already heard a presentation about logistics for food, short distance food, fresh food, locally produced, and the impact if you do that with electric vehicles. So yes, there are huge developments in green logistics, and they are in multiple areas. So 2 areas might be in logistics. The first one is buildings. So if you look at buildings, in the Netherlands, there's not a single building, I think, which is not to some degree green. And so all the, at least logistics buildings are to some degree green, the new ones at least. Why are they green? Well, what is green? You can, of course, ask what is green. But people make an effort to make it green to some degree. They found out that, hey, if you equip it with solar panels, we can reduce the cost of energy a lot. And you have huge roofs on these warehouse buildings. And you can go a bit beyond that. So basically it has to do with energy saving, and that has to do with cost saving. So that's the main driver for being green. And some companies even go further than that, because also the market value of your property increases if you have green certificates. So there are multiple certification bodies. For example, BREEAM certificate is well known in Europe. In the US, you have LEED certificate in the UK. So these are all certificates which have to do with a certain degree of greenness. Not only focusing on energy consumption, but also focusing on insulation, on use of recycled materials, on waste generated. So they focus on many different aspects, not just energy consumption. And you see that the value of your property increases if you have a certificate. So particularly for new buildings, this is extremely attractive to go for. Okay, so the other development in green is in trucks and cars. So we see now many more electric cars, and we also see gradually the first electric trucks appearing. And we not only see electric trucks, we also see in many countries you see hybrid strategies, like why not also go for fuel cell powered trucks, because fuel cells can contain much more energy than batteries can do, and we can travel longer distances, and also the charging time is shorter. The problem, of course, with fuel cells is that the hydrogen costs are still very high, and currently there's in many countries not sufficient green power available to create the hydrogen. But hydrogen is a great storage material for electricity, and so rather than batteries, you can store it easier in hydrogen tanks and then transport the hydrogen. So there's, for example, in the Netherlands, there are huge initiatives for creating hydrogen storage for energy that's harvested by windmills on the North Sea. So we want to create islands where we can store the hydrogen and then use the hydrogen for example, for trucks. So even in warehouses, you now see fuel cell forklifts. So yes, this is a development that's unstoppable. It will continue. But it's still very expensive, the hydrogen, for example. And the question is there sufficient green energy available? Because creating hydrogen, for example, is very low energetic. So it's very inefficient to do that. So, okay, I think I just want to leave it at that. In view of time, let me just go to my final slides. This is my final slide. Technology is bringing great benefits, and many of those will influence logistics practice and research. But to be honest, there's a lot of hype here, an enormous amount of hype. This is the impact of some of the developments on the gross domestic product in the EU. That's the orange line, and in the Netherlands, that's the blue line. And we see a couple of jumps in the gross domestic product of the Netherlands. The first jump is the introduction of personal computers. The second one, introduction of internet. The third one, introduction of smartphones. We see that the jumps are getting smaller and smaller. So all these new technologies leads to a lot of hype, but in the end, the total aggregate effect is not as big as many companies and many people think. So what should we be studying as academics? So how to deploy and control technologies, the impact on performance. And I think the discussion is also about what is the impact on people and how should people interact with these technologies? And I think that's a great research question. And honestly, I don't think the answer can be given in the near future. We still have to do a lot of research to answer that one. Thank you very much.
Thank you, René, for your very, very interesting presentation. Fascinating a lot me. That's I'm working on from the research point of view on some of these items that you discussed in your presentation. Even if I have a copy of your presentation, there are some other interesting aspect and technology that for time reason we cannot discuss in much more detail. So if the other people participant in this workshop agree, I would like to start the panel discussion, the round table. And my first question is just for René, okay? So in the presentation that you sent me, in the conclusion, there was a statement, we need people. So this is apparently a contradiction, considering that in most of the area invested by technology, it seems that the human contribution will be reduced in general terms, I mean, okay? So when you state we need people, can you please qualify this statement in your presentation? So what mean for we need people after a presentation like this?
Yeah, of course, there is multiple answers to this question. It also depends a bit on the sector and the type of technology that would replace these people. So yes, we can see that some of the labor is replaced, but what we also have found out is that it's very hard to replace all the people. Even for simple repetitive work, you cannot always replace people because people are extremely flexible. They can do things that no robot can do, at least not at an affordable price and at the required speed. So why do we see all these collaborative robots? It's because the autonomous robots that can do everything just don't work. They don't work efficiently. So I'm not saying they can never work, but for the foreseeable future, that is the coming 10, 15 years, I don't see autonomous robots, for example, in warehouses doing pick work. Yes, in very specific applications, it will work, but not in general. So we see collaborative systems. So, and also if we do it, we should be careful in what to replace, because if you just replace the picker as a support of the robot, and you let the picker do the unattractive things, or it might be more difficult to find the people to do that even. So you have to be very careful in how you automate. So the first answer is not everything can be done by robots, as we have already found out in many businesses. So even simple things like stock taking, what can be simpler than just stock taking, right? It just doesn't work. Not 100%, not good enough. Maybe it will work in 15 years, but not now. And the second reason is we have to do it carefully, otherwise we also lose the last people. So we should try to do it in such a way that the work for the people becomes more attractive, more interesting. And then we still need a third group of people. That's all the people able to control and design and maintain and do all the analytics behind it. And that's highly skilled people, technicians. We need a lot of other people. So we need people. You're muted, Pietro.
Sorry. So your answer is quite optimistic in terms of future involvement of human in conjunction to technology development in different areas of logistics and supply chain management.
Right.
So this is quite an interesting concept. So I invite the other speaker to ask question to René, so we can do this type of arrangement. So looking at one single speaker after my question, if other question flows, I will be very happy. Any question from the other? Danuta, Dragan? Your mic is mute, Danuta.
Yeah. Okay. My memory is a little bit bad this day, probably. Okay, anyway, I don't have a question for René, but rather a contribution and a comment to what he said concerning human resource management, because I'm involved in human resource management research in logistics for more than 15 years. And I share the strong conviction that people cannot be replaced by robots. Only mass operations, for example, in warehouses, and highly standardized operations can be automated, and the use of robots is much more efficient and effective than. Even there is a concept of a dark warehouse, which says warehouse without lights. Why without lights? Because there are no people, and robots, they don't need any light in a warehouse. But this is a kind of very narrow application. However, it's contributing to the answer, we need people, but the question is, what kind of people we need? It's not that we need all the time people with basic and very shallow competencies. Because even the line personnel, operational personnel, they have to be able to perform these control functions. They have to be able to understand the ICT technologies, and there is lots of stress, even if in operational areas, to these soft competencies of personnel. So, as a matter of fact, if we look at the human personal competencies, we can classify them as narrow or broad. Narrow means more narrow, and shallow would be like competencies of an ignorant. And if we have that kind of competencies in our personnel, then they are useless in nowadays. If they have just shallow and broad competencies, it's like encyclopedia knowledge. They are not very useful either. So what we are looking for, even for operational personnel, is a kind of profound competencies, either in a form of branch expert knowledge and abilities, but what is even kind of the utmost importance in contemporary human resource management in logistics, and perhaps also somewhere else, the competencies, the English people call it a polymath, kind of omnibus knowledge, which means that people can perform different tasks, they can be very flexible, and they can perform different duties. And this is also requested from the from line personnel, from operational personnel, not only from managers. So it's the kind of equipping the operational personnel with managerial abilities, as a matter of fact. And this is the changing quality of requirements for people in logistics. It's not only the numbers, but also the quality. And this is a huge task of education, of preparing these people. So lots of people perhaps do not have nowadays competencies in logistics, which are really allowing to implement efficient and effective systems. This is my point of view, of course. Thank you very much.
Please, René.
Okay, if I may say a few things. First, we are in early age of new technologies. and always we don't know how to use that technologies properly, but we are using them to fulfill the things we know now. For example, maybe René would be against me, but what is the real use of computer in warehouse?
Without a computer, warehouses don't run.
No. Yes, that is. Not to have a warehouse, because computers allow us just-in-time production, and just-in-time production doesn't have warehouses. So that's the idea, because we need a time to put that in line. And as for the people and how these new technologies, especially artificial intelligence, would work, there was 3 years ago in Cambridge, people have made one very interesting research, and they found that in every job, from 30 to 70%, it is now possible to change it with artificial intelligence. Even they say that the manager of let's say marketing is a very innovative job to do, and even there they have found that at least 30% of its work could be done by artificial intelligence. And let me tell you, I'm last year I'm working on that in that field, and let me tell you that the things are not they are more incredible than I even thought they could be. So it is a little bit different. My view is a little bit different, because we are now talking about the technology which doesn't just change the work of people, because before every technology we had has allowed people to work less, but work with hands on physical work. Now we are talking about technologies which are used as intellectual work, to change intellectual work. And I think that there would be a big change, and that yes, we need people, but we need people who we are taught new technologies and how to work with them, and how to create something, and innovations, and these type of things. Well, that's my opinion.
One moment, just some organizational issue. I would like that the colleagues that pose question and allow the speaker to answer. Otherwise, there will be misunderstanding. So, René, would you like to say something about what Danuta said?
Yeah, Danuta talks about different types of people with different skill levels, and I fully agree with that. So we really have to differentiate different types of people. So I don't think blue-collar work will disappear. I don't see it disappearing, at least not in the foreseeable future, let's say the coming 10, 15 years. In fact, what is important is if we talk about training of, let's say in vocational education, we have to focus on people that are able to work with these new technologies. And in fact, the experiment I talked about was done at the school. We did it with students from a student of a school for vocational education in logistics. So they are trained to become logistics workers in warehouses, for example. And we did the experiment with those. And I think these are that's the right target group to test these types of technologies with. And we will still need them in the foreseeable future, because they have to be able to work with them, maybe also to maintain them and do the process control of these types of systems. So we need people with different skills. So I fully support what Danuta said, but I don't see the blue collar work disappearing. Then as a remark to Dragan, maybe, about basically if I understand your main point, Dragan, is that there is an inherent change within the operations, and that since we can use now all the data, process the data, use artificial intelligence to take better quality decisions and guiding us. Yes, I hear a lot about that, but to be honest, I don't see it a lot in warehouses. So we see the use of artificial intelligence, smart algorithms, for example, if you order from Amazon. Yes, you see that in the websites. They look at your past behavior, they do the analysis, they look at your potential interest, and then they show you alternative products. So yes, there is a lot of application, but if you talk about logistics, decision-making, it's a lot less. So yes, we use forecasting, for example, prediction, but prediction can be done with many tools that we know from statistics since ages. And everything we can predict based on past history can be done with other techniques as well. And the question is, do these artificial intelligence techniques go beyond? So prediction is one application area. Another application area is recognition. So we use artificial intelligence for recognition. So if you look at completely automated robots, they're used for recognizing the product, for example, and recognizing what they have to do. And they can do that extremely well using artificial intelligence, like machine learning type of algorithms. So yes, that's a great application area, but it's still rather limited. And so it's not the great breakthrough in use of these types of algorithms. So they're very good at that. But if you go something beyond beyond the training pool, all of a sudden they have a problem. So even if, for example, automated order picking, what is simpler than automated order picking? Recognizing the product, so you get a tote with units, recognizing the product, and knowing how to pick it up. Even that is more difficult than it would seem, because products can lie on top of each other. The box can be dented, or maybe this is not a box, this is a bag. So different ways of packaging products, requiring a different sucker. So even that, yes, artificial intelligence helps a lot, but it does not solve the problem completely yet. So, and I still am waiting for the big breakthrough applications, to be honest. I have not seen them yet. Apart from recognizing products and doing some prediction, I'm waiting for the next great application, but maybe you know more about it than I do. I have not seen it yet.
Okay. Thank you very much. I also have other question for you, René, but in order to give all the speakers the same time, I will postpone eventually my question to you again, because I would like now to pose question to Dragan. Okay, Dragan, following the presentation of René, so I'm looking at your presentation concerning the corridor and next new Silk Road. So do you think that digitalization of corridors could be of help for improving or accelerating new Silk Road? And if the answer is yes, which kind of competencies, of capabilities of people for accelerating digitalization of corridors?
Well, first, I think yes. And if Alibaba can use artificial intelligence to work on the transport in Shanghai and with thousands and thousands of vehicles, why cannot we use it for, let's say, a little less of the ships? And by the way, I don't know if you know, but artificial intelligence is now technology #1 in China, because the government has said that they want to be the first one in that. So they are very, very much pushing in that field. And I think that it is possible. It is possible. The problem is that we don't, let's say, I'm not 100% sure that logistics and especially transportation and maritime transportations are technologies with very high clock speed. So I think that they lack a little bit with other industries, for example, electronics and communications and so on, which are very, very fast in taking new things. And let me, I would like to emphasize what I have said before, because we still, these are pretty new technologies, and we don't know how to use them properly. Because I always think of a very, very easy question. When they made a first locomotive, and how the train was looking like. How was the train? Because they didn't know what train is. They just took the coach and put it on the locomotive. So it's the same thing we are doing now. And maybe the technology, we are not using technology as good as it should be done, because we don't know how to do it, because we are not yet didn't yet understand how to use it, but we are using it just to pass what we need now, because we have problems, and you use this technology to overcome that problems, but not as it should be used, let's say, in 5 or 10 years. And I think that René has right. At least in 10, 15 years, we wouldn't see completely that this technology would change. The people would change a little bit by bit, how people are working. And sometimes it would be faster, sometimes it would be slower. For example, we are now having a webinar online. If there was no COVID, we wouldn't do that. So we wouldn't use the technology for that. So it's just we need the time to see what the new technologies are, and then of course in that 10, 15 years we will have a new technologies, and new. So that is what I think.
Okay, Dragan, thank you very much. So other question from the other speaker or from the other moderator, Danuta? Do you have any question for Dragan?
Yes, just the question that I already mentioned when we finished Dragan's presentation, because I'm a very business-minded person working mostly with companies, and I was sort of I think that, for example, such large global concepts, like, for example, as an example, the new Silk Road, these are just political and promotional concepts working well for some parties, some countries, some political powers, and that's fine. But my question is always, will business need it? Because everything here, in many instances, also in the case of use of new technologies, is that there is a requirement for that. There is an old proverb that the requirement is the mother for inventions. So you will try invent things and apply them if someone requires it. If not, then it's obsolete. So I guess that even in recent years, when we talk about, for example, in computer revolution and revolution in application of different systems, a simple example: for years, the parcel deliverers, the couriers, they used to have, they were obliged to have a physical signature of the recipient of the parcel. They don't need it anymore, okay? So there is a system for that. So we really went through a real, let's say, e-commerce revolution within, let's say, 1.5 years, that's all. And we are at the completely different level right now. What about Internet of Things, which is so frequently, I mean, it's starting because the use of every technology has to start somewhere. But I believe that there is a necessity for that technology, and that it makes sense, because if it is not necessary, so let's wait until some better opportunity. So my question to Dragan is that really a kind of realistic necessity and requirements for that kind of new Silk Road development, not looking from the point of view of big political powers like China, because evidently it's serving Chinese purposes. What's in it for Europe, for Balkan countries, and so on?
Well, first of all, let me tell you that there was a part of the presentation which shows how long you need to get goods from China to Europe. So if you go by train, it is 10 to 15 days. It's 15 days, but with 50 kilometers per hour train. So it's if you put it a little bit faster, it will come up to 10 days. Instead of that, using maritime transport, you have one month. That's 30 days. And in these days, companies and people are want everything fast. You know, that's one thing. And second thing, what I think what our Chinese doing is that the fastest route to the Europe is through the Mediterranean and South Mediterranean. That's why they have took the port of Piraeus. And if you have seen what they are thinking of is to create a fast railway from Piraeus to the Budapest and then to the other parts of Europe. So it's this is what could be, for example, if you look logistically, that is to take the fastest route and to get fastest the goods to the customers.
Yes, but my question is oriented towards the requirements in terms of the cargo. Is there a credible prediction that there will be enough cargo to be transported, well, by trains, but mostly by ships? And even now, we know that there is a big growing demand for maritime transportation. Prices of container from Shenzhen to Europe are growing up terribly. So we have to also to take to account that maybe in near future, the demand for carrying cargo for that kind of long distances, especially that we are witnessing the shortening of supply chains, not only food supply chains, but all kinds of supply chains, and inshoring of production and everything. Is there a credible forecast that will actually prove that it's worth doing to revive the long distance Silk silk supply chain? This is exactly what I'm concerned. I don't have an answer to that. I just would like to know your opinion on it.
No, neither do I. But I think that sometimes, as you have seen, sometimes when you have for example, what if something happens to Suez Channel? Then we will not have 30 days, we will have 2 months, because the ships should go around the Africa. Second, would there be a demand? Of course, China is growing and their wages are growing, and but they are also thinking of new, not the markets, but new, let's say, countries where the production could be done, and that's in Africa. And if you see, the Silk Road is going also to Africa. So I think that somebody has calculated a lot of things before making that idea, because so not only for current things, but when they have proposed the idea, is they have also thought, let's say, 20, 50 years in advance, because it is possible, very, very possible, that the next, no, don't say China, but as countries where the labor is low, low wages for laborers are low, are going to be countries in Africa. So this is what, and we will have the same thing.
Okay.
So I really don't know the answer to you, to tell you, but there are some possibilities. There are possibilities that the logistics path would be changed with this one road, one belt. There is a possibility, and we have to look at it. Maybe not now, maybe it will be in few years, but look, the Chinese have very, very, how to say, very strong way to work with companies, because they not only their companies are coming as companies as ours are, but their companies are backed up by the government. So you have the big problem with working with them.
Okay, Dragan, thank you very much and Danuta for your question and answer. I would like to pose question to Andrei that make a presentation on very interesting part of our field that probably under-researched. And as technology, and specifically digital technology, are investing all the fields, and then also in rural areas, we have to expect that the use of technology will increase in the future. As in your presentation, you show something in that direction. So my question is, according to you, which kind of technology, emerging technology, will be mostly used in the context of rural areas and then rural transportation and logistics? And specifically, which kind of competencies do you think are necessary to manage short supply chain in the near future?
At Faculty of Logistics, we are dealing also with these competences for our students. And we are teaching the things for logistics in digitalization also, because the students and also the farmers should be known a lot of things, how to produce the products, also how to sell them through internet, through telephone. These applications are very important that they can sell the products. Also, the industry is moving back from China to the Europe, some of them, because the transport prices are growing up. And these sort of supply chains are really good for especially food, because we need, let's say, for potato, for fruit, for vegetables, really short supply chain. Not that we are buying the products from Greece or Spain in Slovenia, if we can produce this in our country. And also for your countries all over the world is this very important, because we should be environmental friendly, that we don't make so much kilometers for food, which could be bought locally.
Thank you very much. Any other question from other speaker or moderator? Okay, I have another question for you, right? So typically in logistics in rural areas are more often costly than logistics in urban areas due to small scale or manufacturer and scattered of settlement. So in your experience, how to manage the two key objectives of logistics, that is increasing the customer service level and reducing costs through the help of technology, maybe?
A very good question. It's not easy answer, because
do you have some example, for example, in your experience coming from your research that you can?
Maybe the price could be lower, and also then the distribution of the food could be from one point, from origin then to destination, cheaper if you buy more products. And also the economy of scale is also here important. And maybe that farmers got together with different products, and then you buy from one store, or let's say from different farmers, a lot of products, then the price could be even cheaper. And also the distribution or logistics in that manner also. And some of them are selling without any special transport price. But some of them, they are raising their products price, and is also incorporated transport in that manner. Some of them, if you buy, let's say, for 50 euros, you should pay them for transport 5 euros. And this is one of the example which could help us which way to go, or you pay for transport exactly something or not that is included in the price.
Okay, well, this is quite interesting to me, because as René Dragan mentioned, artificial intelligence, for example, is finding very strong application in the logistics, especially in the future. So I was thinking that, for example, precision agriculture that is strongly based on the use of technology, maybe also used for supporting and makes much more efficiently agriculture production in rural areas, and also contributing to decreasing the cost of logistics, assuming that in that areas logistics typically is much more costly than in other areas.
Yes, exactly. And we should be aware that also these farmers or the producers should be educated in that way. So I suggest that all these young people or older people are educating in that field, that could be more effective and efficient.
Okay, Thank you very much. Any other question for Andrei from the speakers and moderator? Okay, thank you very much, Andrei. I will pass to the last speaker, that is Maria. Maria is with us or not? I don't see her. She left us. Yes, she left us. Okay. Okay, so we have some other 5 minutes before to concluding. I have another question for René, because his presentation piqued my brain in several ways. And for example, in your presentation, you talk about platooning, track platooning, okay? Please, can you say something about why you are skeptical about, because I read many reports in which platooning, track platooning is considered something that can give to freight road transport some better efficiency, reducing the environmental impact, okay? But from your presentation, I understand, maybe I'm wrong, but I understand that you are quite skeptical about the future development of track platooning at a higher scale than today.
Yeah, maybe it's just because I'm a skeptical person, Pietro, I don't know. But so many of these applications they promise a lot, but when you try to do it, usually in practice, the results are not so good as hoped for. And so with what is truck platooning? So basically it's, you form a train of trucks, and then the train, well, the idea is then you can save fuel because they drive in each other's vortex. So therefore you have less resistance of the air and you reduce the fuel consumption. That's assumption 1. Number 2 is you can do it driverless. So you can drive these trucks autonomously without any driver. That's the second promise. These are the 2 major promises. So saving energy and doing it driverless. And then, of course, if you do it driverless, there are a lot of implicit benefits, like, okay, driverless, but that means you can do it 24/7. You can do it in weekends. You can. So the truck, now the driver has to stop because the driver needs to have a sanitary stop or need to eat and drink something or to sleep, whatever. Now these trucks can be used much better. So that's huge promises from such use of the trucks. So there have been a lot of pilots in the meantime. So this is piloted since, I think, at least 6-7 years. There are huge EU subsidies for platooning type of research projects. And there are quite a few companies who have been involved in these types of experiments. So many countries have seen experiments with truck platooning. What comes out? First, you cannot do it without drivers currently. It's too dangerous. You just can't do it, so you still need a driver. And what is the problem with the driver? Well, a driver who doesn't have to do anything falls asleep. And when the driver has to interfere, the driver doesn't do it. So it's even more dangerous sometimes. Second, the fuel saving is far less than ever assumed. So in theory, you could assume, let's say, 4%. Practices from MAN, for example, they came up with savings of 1%. Well, 1% fuel consumption reduction is just negligible. So it falls into the margins. Then the problem with a platoon is, how do you form a platoon? You need to create a lot of trucks going in the same direction. They come from different origins and they go to different destinations in the end. So you can share a part of the journey, but you cannot share the entire journey. How to create the platoon at the moment you want to send your truck, right? So do you have to wait now somewhere in order for the other trucks to be there to form the platoon? So the to and from transportation is still manual to start with, and it's very difficult to organize. So adding up all these different aspects means that I don't see it happening in the coming 10 to 15 years, at least not on a commercial basis, when the subsidies will stop. When the subsidies stop, this stops. But I'm not saying it will never happen. So maybe in the future, when they can really do it autonomously, yes, okay, then of course it's a great concept. If you really can do it without drivers, electric trucks, or yes, I cannot see so far in the future, but for the short-term future that I can oversee, I don't see it happening.
So
I'm a skeptical person, so So maybe some of you are different. I'm just skeptical by nature.
No, behind this, but this is the perfect example of technology in which it's impossible or almost impossible, very difficult to completely substitute technology with human, with the drivers, you mean?
Yep.
Okay, okay. That's very, very good point to me. Okay, we are in perfect time. So we, thanks to Danuta to conduct in a very efficient way this event. So we are just going to the conclusion. I would like to thank Danuta for his work, and especially the other Dragan, René, Andre, and Maria for their presentation. Very interesting. The interest of this workshop or webinar today was that apparently the topic was completely different, but we found out a very nice and very common base, that is technology and the impact on human resources. So personally, I'm very happy because I learned many things today, and I would like to thank you again for participating, and I wish you a nice weekend. So bye-bye, and thanks a lot, and see you again soon. Bye-bye, René, bye-bye, Andre, Danuta, Dragan, and
bye-bye. Thank you very much. Thank you.
Thank you.
It was nice to meet you all.
All right, all right. René, what you just said?
Thank you all for the presentations and for being here. So
All right.
nice to see each other again, right?
Yeah.
Okay, thank you very much. And
Thank
keep in
you,
touch
bye-bye.
soon.
Bye.
Bye-bye, Andre. Thank you very much for your presentation. Bye-bye. Thank you very much.
Bye.
Bye, bye.